Hello, we are team number 12, and today we're going to present the paper from Facebook AI, Unsupervised Cross-Lingual Representation Learning at Scale. So, before going deep into the details of the paper, we are going to introduce the background and the related works of this paper, and we'll finish by telling some current works about it from 2020, the date of the paper, and now. So for the background, we are now in 2020, and one big trend is around the BERT. BERT is well known and you know it. It's a massive language model based on the transformer architecture. And what's very interesting about this model is that it can do a lot of NLP tasks with at most some fine-tuning, so for instance sentiment analysis or spell detection. But however, BERT is an English-centric model, which means that he has been trained and trained on the English-only corpuses, so that he can do well NLP tasks, but only in English. But what if we want to do this task in more than one language and English? This is then when we talk about multilinguality. And the goal is to create a shared language understanding between every languages. It seems very simple at first, but there are many problems. So one of the biggest issues is the lingual resources, which we'll just talk about. So there is a huge data imbalance between every languages. So for instance, I used the OSCAR dataset, which we'll talk about later. And on this table, we can see that the English language has 1 million words, more than 1 million words, more than the Swahili language. So that's why we can see there is a huge gap between these languages. And so we talk about, for instance, the Swahili of low resource languages. So up to 2020, how we did with this kind of multilinguality. The first method was to use machine translation, which is basically just translating one text in a language to another language. So I've illustrated with two examples. The first one is if you want to do some NLP task with BERT, for instance, sentiment analysis, with another language. So we basically just translate the other language text in English and then do the task. And the other example is to fine-tune BERT with a specific language. But since the low resources languages and other languages doesn't have a lot of datasets available, labeled datasets, we can use an existing English level dataset, translate it into the other language, and then fine-tune BERT. The second method is what we can call like multilingual training, which is more about what we will talk about later, the XLMR. So I illustrated two things. The first one is multilingual BERT, which is from Google. And basically they are just using the pre-trained BERT model in English and making some alignments and adjustments to make it multilingual so that it can do multiple tasks in multiple languages. And the other one is the previous work from the paper we're going to present, which is XLM from Facebook AI. And they didn't use the pre-trained BERT, but they pre-trained it from scratch. Using new objectives, as we just saw, like the translation, the language modeling. And this model is cross-lingual. That means that in addition to being multilingual, it can transfer knowledge and capabilities between two languages. So now we are going to talk about the following of XLMR.
Starting from this section, I'll describe the detailed methods applied in the paper XLMR. So this is the training objective of XLMR, which is the paper that we present. And the previous work is XLM. So for training, there's three different objectives. The one is CLM, the causal language modeling, and this is unsupervised. And MLM, the mask language modeling, this is also unsupervised. The third one is the TLM, the Translation Language Model. This is the supervised. By the way, this is the present slide from professor like 10 minutes ago. And the TLM is a task where you concatenate a pair of sentences translated in one language and the other language. So like one language is in English and the other sentence is in French. And then you apply mask on this pair of sentence and then try to predict the mask tokens. This is the objective of TLM. And this is the key contribution of this paper. The thing is that they enlarge the training language models at scale. So basically, they enlarge the data set into multiple times. So they argue that larger training set leads to the better performance. So they created more than 2 terabytes of data set built upon a filtered common core data set. So they call this data set as CC100 with 100 different languages. And if you compare these two, this red bar indicates the number of the sentences at the dataset size used in the previous papers. You can see that they created more data set and they trained a model in a more larger data set. And they also tweaked the training lesson from previous work. So first, they sample their language more often by reducing ARPA to the smaller values, such that the rare languages with a rare data set would be sampled more often. And also they improved the tokenizer and the vocab size. So for tokenizer, instead of using a BPE tokenizer, they used the sentence piece tokenizer.